Hello, everybody. Happy Wednesday. Today's live class I'm re-recording because once again, for some strange reason in this class, somebody when they joined the Microsoft Teams live stream probably accidentally tried to record the stream and it ended up messing up my stream. Now, we knew this during it because a couple of you reminded me of that, but in the end, what ended up happening was the video was just all chopped up and just a kind of a big mess. So I'm going to instead switch up to what you're seeing now, which is I'm going to go back over all that content. So this week, from our website to Computer Science 40S to where we are now, right here in week 12, as it is May the 6th, we're going to start looking this week at our collections unit. Okay? Last week, and I recorded the video of that, I finished our look at the advanced classes example and went through the advanced classes assessment. So if you want to go back and look at that from last week, you should see all of that there. Okay. This week, I'm going to start my look at the collections example. We will not finish it. It is also a long unit, and that will continue on into next week as well. If things go well, we'll also maybe take a look at the collections. Pardon me, the collections assessment next week. If not, we'll just push that into the week. So what you guys will be looking at this week is an accelerated version of me going through this example right here. There's an archived version of it right here. You can take a look at that example. But honestly, the best way to learn about collections is not to just watch this accelerated online class, which I'll be just doing the example and updating our GitHub page. But you want to go through the collections videos. There is 12 of them, okay? Some of them are quite short. Some of them are quite a bit longer. And it really covers the content of the collections unit. Alternatively, if you don't want to sit through all the videos, you can read through the PowerPoint notes. There's 71 slides here about what collections are and how they're used. It also, throughout this, includes the code of what's being covered in collections as well. So all of that is important because obviously I would be teaching this live in class. So if you want the live class experience, rewatch the videos. This online class just specifically targets the example. All of this stuff is in the notes. Okay, it's in the folder. So you can go into that folder and get the lecture notes. You can get the example. You can get the assessment. You can get a review, even though there's no test. All of that's in there. Okay, the videos are there for you. And the other thing I wanted to cover just before we dive into the example is I've opened up here the U of M's Department of Computer Science and a list of their undergrad courses from the first year or the 1000 level course. And we're going to take a look at this Intro Computer Science 2, the second course you take in your first year. Open it up. Take a look at this course outline. And one of the major topics of this unit, the linked list, is covered in that course, including something called the node class, which we're going to do today. So you're looking at some university level content, but I'm going to step back a bit and actually jump to the second year course, and this one called Data Structures and Algorithms. Look at its course outline. And here you can see as well in the second year course, linked lists are again discussed in much more detail of some of the content here. And that's where this unit's going to go. It's going to go into a lot of detail on the linked list, which means you're going to get that much further ahead in terms of your studies than a normal high school student would do. Okay, so that's all there for you. The collections content. Let's take a look at the example that we did live. Unfortunately, the video didn't survive. So if we go back to our main class in our project, we do an output and then we make what's called a tester file. The tester file does some outputs and then it launches different classes for recursion, advanced classes, and now one for collections test that will run individual tests. Now, for purposes here, I'm actually going to comment these two out. I only want to run the collections test. Okay. And let's take a look at our project right here. So now that was the original class with main in it. This was that tester class. And now we've added this thing called the collections test. What I also want you to do is add a package, another package to your project. collections package. And into that package, I want you to put two more classes. One called link list with a capital L for list, and one called node. Okay? And unlike the last unit, these are the only classes we're going to be adding for this whole unit. So just these three classes. I know back in this one, we added a ton of classes, but that was because that's what that unit focused on. Okay, so from main to the tester, from the tester to collections test. Now, all of our code's going to be going in the constructor, but I also want you to add a little private method to this class as well, just called comment. It takes one parameter, a string of text. This is just something we're going to use for simpler outputting. I'm going to show you the code. Now, I didn't actually do this during the live video today, but it's up in GitHub now, and I want to sort of go over it. Essentially, what I'm going to do is use 80 characters long. So I'm going to calculate based on how long the parameter is, how much remaining to get to 80, add a bunch of dots to the end of the line, and then use these two little finals to change the color in the output. That way, when I put a comment there, it's going to look a little different than the regular output that we're going to do. Okay? And then the code goes in collections test. Okay? Now, for now, I'm just going to comment this out. Okay? And run this to show you what calling this method comment looks like when it's run. So there you go. It changes the color and adds a whole bunch of dots up until it gets to the 80th column there. Okay? So now what I want to do is build some node objects and test the node constructors. So what we then did was we built a node class. Public class node uses a generic data type T, and we made 3 properties for the node class. One is the data, and the data uses that generic right there. So it's a generic type. So this is a node of what could be anything. It could hold integers or strings or a class or a custom type like type person. Then what these two things are, as you can see, they're what's called a self-reference. It's a node referencing a node, okay? Connecting to the next node and connecting back to the previous node. So the idea with this is it creates a linking structure. So we have this thing called a node, and it references or it links to the next node. Okay, and then it also links back to the previous node. And if that is another node, then we're going to have linking back and forth, right? And that's the idea. It's creating a chaining type effect from one node linking to the next. When we eventually get to the end, whether it's on this side or on this side, it's going to link to null, which indicates that that's the end of the list. So the node is used eventually by the linked list to create this chaining or linking type effect from one node to the next. We then made a node constructor. The way the node constructor worked, which you can see right here, is I pass it the 3 parameters, data, next, previous, and then assign them to this object. So this particular node object gets assigned all the parameter data. We then overloaded the constructor with a second constructor, which only has 2 parameters, not 3, just data and next. And I showed you a neat little trick where you can use one constructor to call upon the other constructor. Makes it a lot less code to write. And we ended up doing that again for another node constructor with just data. And then a 4th time with a node constructor that's the default with no, and we just pass it 3 nulls, which means it would have jumped back to the original constructor. Whoops. Right here. And put null, 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 and assign null, null, null to this data, which is the data up here. Okay. So that was our node constructor. So in our testing class, let me just close these two. We tested that. We made 4 node objects. Node A using the default constructor, node B using 1 parameter, node C with 2 parameters, node D with 3 parameters. Okay? Now making them is one thing, right? Like we can make these nodes, but that doesn't actually show anything when we run the output. It just shows that we built them and it didn't crash. So then what we did in the node class was we overrode the toString method. It's really just 2 lines of code. If the data inside the node is a null, then return the word null. Otherwise, return whatever the data type is. If it's type person, if it's type Husky athlete, call upon the built-in toString method, which we know is built into every single object. And so that's how we could turn our nodes into strings. So using the overloaded toString method, we tested that. And again, here's me using that little comment method. And so now you can see that when I tested that toString method, there's the A, B, C, and D. A was a null, B, C, and D all contain some data. Okay. Then what we did with the node class was we overloaded the equals method. And this is probably the most complicated method of the node class. We did a little error checking. If this node's data is a null, return false. So it returns true or false or 2 nodes equal. What it's checking is an object. That's the parameter, an object. If that object is a null, again, return false. So these 2 little error checks stop the code if any of those 2 things are a null. Then this line, which is the strange line, takes this object and casts it into a node object called that. So that is now a second node. So we have this node, which is the node we're in, and that node, which is the object cast into a node. So if that data is null, again, I can just return false. The method's over. But if that is not null, then I do the final line of this method, which is to check if the data inside this equals the data inside of that, calling upon the built-in equals method of whatever the data type is. Okay? So by doing that, I can then test the equals method, which we did. We ran that. And nothing should be equals at this point because you can see right here, A, B, C, and D are all different. So none of them are equal. Then we went to the node class and wrote the clone method. This is a really easy one. We just created a brand new node. We didn't even give it a name, which means it's an anonymous object. Passed it data, next, and previous, which used the constructor to build it. We tested this by cloning D, the node D, and creating a node called E, which is a new node. We then checked to see what node E looks like by outputting it as a string, and checking to see if D and E are equal, which they now should be because we've cloned it. And we ran that test. And sure enough, D and E are equal because node E is bananas and node D is bananas. I feel like singing the song, but some of you know what I'm talking about. Anyways, so then the next thing we did in the node class was we then, like the equals, toString, and clone methods, which were covered in the last unit, I then introduced one last method for the node class, another method that overrides a method from the object class called finalize. This is a method that's called whenever a node object is destroyed or deleted. So how do I delete a node? Well, set the data to null, set next and previous to null, those are the references, and then call upon this, which I introduced, which is a call to the Java system garbage collector, which automatically cleans up memory. So we tested that. We finalized our brand new node called E, which was the clone of D, and then outputted it. It had bananas in it, but now that it's been finalized, or essentially wiped out, now node E is null. It is no longer containing data. And if we wanted to, I didn't do this in the example, we could even check to see if node D and E are equal again, because they shouldn't be now, because now node E is a null. And yeah, they're not equal anymore. Okay. Okay. That concluded our look at the node class. If you go on to GitHub, you should be able to get all this code along with all the comments that I've included. Even at the top, I included a little picture, which I drew in comments, of what a node would look like, that it holds generic data, and has a reference to the next node and a reference back to the previous node. And then we now went on to the linked list class. Once again, this class uses generic data type. Okay. It had 3 properties: a node reference to the head of the list or the front, a node reference to the tail of the list or the back. We don't necessarily always need both of those, but we did create them so we can enter into the list from either the front or the back. And a simple integer that keeps track of how many nodes there are, or a list of nodes. Okay. We had one more public property for this class. These other 3 were private. And that is something that's going to be used later in this example, something for when something's not found. So it's a constant whether or not something is found or not. And we're just going to use -1 to indicate it's not found. Okay, so those were our 4 properties. For our constructor for the linked list, we called upon finalize. So we rewrote a finalize method for the linked list, setting the length, number of nodes, to 0, setting head and tail to null, and calling upon the garbage collector again. So that's how we wipe out or finalize a linked list. So we tested that. We created a linked list, as you can see right here. Linked list of integers called list1, we're going to make multiple lists, equals a new linked list. And we ran it, and it didn't crash. It created a linked list. The next thing we did in the linked list was to write 2 little methods, one to check to see if the linked list is empty, and one to determine the number of nodes or the size of the list. So looking at this one first, all it does is return the length. This is an accessor method. It accesses the length, which is a private encapsulated property. We do not want to be able to change the length outside the class, which makes it immutable, which is why we don't write a mutator method for this. And it's also why we don't make the length variable public. The isEmpty method returns true or false, which is why we use this sort of shorthand here to just make it a 1-line method, because normally you'd see this inside of something like an if statement, if length equals 0, but really that is just true or false. And so it can be, this line of code can be shortened down to just that. Okay. We ended up testing those 2 methods. Okay. And I will not use this one yet. But we can check to see if it's empty, and we can check its size. Yes, it's empty. Size 0, because we just built it. We also then took the time to write 2 big complicated methods to add to the front of the linked list, and then subsequently to later add to the back of the linked list. So I'm going to go in detail through add front, and then much more slowly and much more quickly through add back. Okay, so the first line says, okay, so you've been given some data to add to the front of this list. Well, if that data is a null, return false. This is why we made this method a Boolean method instead of a void method. It shuts the method down on this very first line. If we have no data, we're done. If we can get past that first line, then what it ends up doing is it makes a node object. I'll draw it like this. This object is going to be called node. That's the name of it. I'll show you that. Right here, you can see that's the name of this thing, that it's a node. It takes the data right here and places it inside the node. So the data is stored inside that. That's the same data from right here. Right? Okay. When I call that node constructor, this is set to null and this is set to null. Okay? And then it's done. So that's done. And now it comes to here. Is it an empty list? Well, if I'm adding a node the very first time, it is an empty list. So now my reference called head and my reference called tail, okay, they reference this thing. So tail equals this new node. Head equals this new node. Okay, and that's done right here. Doesn't do the else. Adds 1 to the length. So now length is length 1, not 0 anymore. And returns true, I was able to add data to the linked list. That's how the method works on an empty list. If I call this method a second time, data is not null, so now it goes to this line. Now, this is no longer called node. Now it's going to build another new node. Now the new node is called node. It has the new data in there. Makes this a null and this a null. Okay. And now it comes back to this check. Is it empty? Why, no, it's not empty. It's not empty anymore. So now this piece of code doesn't execute. And now these 3 lines right here, the 3 important lines, are going to execute. Okay? It's still going to do this. It's still going to go up to size 2. This is still going to happen. And it's still going to return true. But let's take a look at what these 3 lines do. Starting with this first line. Node, that's this thing. Dot next, that's this thing. Equals what the head reference is. So it now points it to this right here. It's no longer a null anymore. Okay? Then it goes to this line. Head, that's this thing. Dot previous means it's going to be referencing this thing right here. This is not going to be a null anymore. Equals this node, the one called node. So it links it back there. And then it finally goes to this line, head, which is right now pointing to that old node, now references our new node. So that's how it adds a node to the front each time of this linked list. So that was the detailed explanation for that. To test that, we ended up creating a bunch of constants. Okay? We ended up running a loop 5 times, creating an integer randomly between 0 and 9, turning it into from a primitive integer into a class type integer, adding that integer to the front of the list, and then outputting the size of the list and then the list itself, which is why we then went on to write the toString method for the linked list class. Okay? And the way this works is if it's an empty linked list, we just return the words empty linked list, and then we're done. But if we get past that first line, we start a string of text with the words linked list in it. At the end of this method, we'll return that text and the closing square bracket. And then we use these lines of code to loop through everything in the linked list, starting at the head, while we're not at a null, move current to the next node, pull out the toString of each time current is on a node, and add a comma on there, okay? And you can go through that in more detail. I've added comments in here, and that would then output the linked list as a string. Anyways, so now we can see what it looks like when it's empty, and then what it looks like after we've added 5 random integers to it. So let's test that. And there it is. So here's what it looks like when it's empty, an empty linked list. And then here's what it looks like with different things and different sizes added to it. So put a 2 into the linked list, and then it added a 1 in front of that, and then a 1 in front of that, and then a 1 in front of that, and then a 4 in front, in front, in front. And it's random, right? So if I did it a second time, I'm going to get different numbers. As it randomly adds things to the front of this linked list. We then went and wrote a add back method. Now the add back method is identical to the add front method, other than the name changing here, obviously. This line is exactly the same. If the data is null, return false. It still creates a new node. If it's empty, right here, it still sets head and tail to that node. It still adds 1 to the length. It still returns true. The only difference is in these 3 lines. In those 3 lines, I introduced the idea of a dual operation, which is a mathematical term and a computer science term, which means every operation has a dual or an opposite operation. Just like multiplication and division are opposites, addition and subtraction. So every place we had the word next became previous. Every place we had the word previous became next. And every place we had the word head, we switched to the word tail. And this reverses the logic, and now we can add to the back of the linked list. So along with our toString method, okay, we were then able to test how to add things to the back. And then finally, we also tested the finalize method. So after we added a whole bunch of things to the front and back, we wiped out the linked list with finalize and tested that. And there it is. Test add front, test add back. So you see this 0 would be somewhere in the middle of the linked list as it adds stuff to the front and stuff to the back around that. Okay? So this shows some of the, and then of course we finalized it and wiped it out. Some of the flexibility of the power of what we're going to be doing with this linked list. Much more powerful than an array. Okay, everybody, I'm going to wrap up this video right here. Now it's time for me to wrap it up. And remember, next week, join in, but please do not try to record the stream or end up having to redo it all over again. Okay, guys, stay healthy, stay safe. I will see you next